In MCQ 21, there's a question for us to find out which pair of the species are carbocation. As a little bit of a reminder, carbocations are compounds that have a positive charge residing on carbon itself. In organic chemistry, this is often seen under alkene. When alkene undergo electrophilic addition reaction, the slow step will result in a product that is a carbocation. You will also see this under a tertiary halogen derivative, when it actually undergoes the process of an SN1 mechanism, and the products of the slow step is once again a carbocation. But for the context of this question here, we're just going to look through each of the options, drawing out the Vesper, and to check where the positive charge is actually residing. For the case of A, we're going to have CH3, CO with a positive charge, and that positive charge here means we have to lose an electron from the least electronegative atom. So between carbon and oxygen, carbon is considered to be least electronegative. Carbon will be my central. So double bonded to O, single bonded to CH3. And initially, before losing the electrons, there's one unpaired electrons on carbon. So by losing it and forming a carbocation instead, this now has a linear configuration of 180 degrees. So any option with CH3CO+ is definitely a carbocation. I will have A as well as C for the consideration, but not for B and D. Now the other member in the pair here is going to be a CH3OH2 with a plus. This time around, oxygen would have been the central atom, and the element that has to lose the electron is going to be that for hydrogen. So we will have a H plus instead. Already offhand, you can see that this is not a carbocation because the plus charge is not on carbon but rather on hydrogen. But just drawing up the structure here, I will have O bonded to a CH3 bonded to a hydrogen. At this instant, for oxygen, there is a total of 4 electrons that's unpaired, or 2 lone pairs, of which one will actually be used to form dative bond towards the H plus itself. So this actually becomes the configuration of one lone pair with 3 bond pairs. One for CH3, one for H, and one for the dative bonded to H plus, and this gives us the configuration of that of a trigonal pyramidal structure that comes with the bond angle of 107 degrees. But nonetheless, this is not a carbocation because the plus charge is on H plus. So anything with this is considered to be wrong. So it's going to be wrong for D again, as well as wrong for A. That means the correct answer here could only be C. But let's just draw out the options for C here, which is that of CH3, 3 of your methyl bonded to a carbon. Similarly, drawing out the Vesper, you can see that it's going to be single bonded to each of the methyl. And at this juncture, there should have been 1 valence electrons left on carbon that is unaccounted for. And for this to be a plus charge here, we will lose this single electron, and the carbocation is found on the carbon itself, showing that this is another carbocation intermediate. So C is the correct answer here.